Here we are solving January 2024 Pure Math 3 paper. In the previous video we looked at question number 1 to 3. Now let's start with question number 4. We need to combine these two algebraic fractions into a single fraction. So first thing, we will factorize it first. Use our calculator to factorize it. Go to equation number 3. Put the coefficients there. Coefficient of x square is 3, coefficient of x is 7, negative 20. So we get 5 over 3, x is equal to 5 over 3, and the second value is negative 4. What does that mean? You can write f of x is equal to 2x square minus 32 divided by, put it as a factor. You can write it as 3x minus 5, x plus 4 using these two numbers. But you need to be very careful here. You always check when you multiply these two, you are getting the first term of this or not. Because if the function has a common term, a common factor, you won't get it actually. So you need to verify that. So for example, let's say the function given here is 6x square plus 14x minus 40. So I'm going to do it in my calculator now. X is 6, A is 6, B is 14, C is negative 40. You will still get the same answer, 5 over 3 and negative 4. So if you multiply these two, you won't get 6x square. So what do you do in this case? You multiply these two, you get only 3x square, but you need 6x square. So it has to be multiplied by 2. That 2 is a common factor. Just put it here. That's how you factorize it using calculator. But in the given function, you don't need to worry about it. Just write the factors. We are getting 3x square plus 8 over 3x minus 5. So to make the denominators a common one, I'm going to multiply and divide by x plus 4. So we have a common denominator, 3x minus 5 times x plus 4. Don't open the bracket again. Keep it in the factorized format. Here you have 2x square minus 32. Open the bracket here, you will get 8x plus 32. The minus 32 and plus 32 can be cancelled. You can take 2x as a common factor. You will get x plus 4 divided by 3x minus 5 times x plus 4. Now we can cancel the common factor x plus 4. We got the answer already. 2x divided by 3x minus 5. So just write 2x divided by 3x minus 5 now. That's all. Let's move on to part B of the question. Show using your calculus that f of x is a decreasing function. We got f of x as 2x divided by 3x minus 5. For decreasing function, the condition is the first derivative should be less than 0. It should be negative. So we need to find the first derivative. I'm going to apply the quotient rule here by taking the numerator as 2x. So u dash is 2. Denominator as v. So v dash is equal to 3. So the quotient rule is f dash of x is equal to vu dash 2 times this minus uv dash, which is 6x divided by v square. So when you open the bracket, you will get the 6x can be cancelled. 2 times 3 is 6x. So you will get negative 10 divided by 3x minus 5 whole square. Now look at this function. 3x plus 5 whole square is always greater than 0, right? It will always be positive. So the denominator is a positive number, numerator is a negative number. So you can say, therefore, f dash of x is a negative number, less than 0. And then the conclusion, therefore, f is a decreasing function. You need to write the conclusion. F of x is a decreasing function. That's all. Let's move on to part C of the question. We have g of x, we need to find g inverse of x. Just make x as a subject. G of x minus 3 is equal to 2 ln x. Divide by 2. So you'll get ln x is equal to g of x minus 3 divided by 2. Remove ln, so x is equal to e to the power g of x minus 3 divided by 2. So from here, replace x by g inverse, replace g of x by x minus 3 divided by 2. But there is a problem. If you write just the inverse function, you won't get 3 marks, you will get only 2 marks. Though the question asks you to just find the g inverse, you have to find the domain of this function. You need to find the domain of this function, otherwise you will lose 1 mark. So the domain of g inverse is same as the range of g of x. The range of this function. What would be the range of this function? So I'm going to show you the graph now. This is the graph ln x with x-intercept 1. Even you take 2 ln x, it's just a stretching, will not change the x-intercept. Now when you add 3 to the function will move upwards 3 units. So the function will be somewhere here. That's 3 plus 2 ln x. Now if you find x, the domain is x is greater than or equal to 1. So when you put x is equal to 1 into the function, ln 1 is 0, the y will be 3. So for the corresponding to this domain, the graph corresponding to this domain is this. That means basically it takes more than 3, all the values more than 3. So the range is g of x is greater than or equal to 3. That would be the domain of g inverse. So you need to write comma x is greater than or equal to 3. That's the domain of the inverse function. Part D now. So find the exact value for which g of f of a is equal to 2. Basically they want you to solve this equation. We know f of x is equal to 2x divided by 3x minus 5. So f of a would be replace x by a, 3a minus 5. And we know g of x is equal to 3 plus 2 ln x. So g of f of a would be same as g of f of a is 2a divided by 3a minus 5. So in g of x, in the place of x, just sub in this one, equate it to 5. So you will get 3 plus 2 ln 2a divided by 3a minus 5 is equal to 5. And then solve for a. Bring the 2 to the other side. 5 minus 3 is 2. And then divide both sides by 2. You will get ln 2a divided by 3a minus 5 is equal to 1. Hope you understand this step. If you remove ln, the other side become e power. E power 1 is e. So 2a divided by 3a minus 5 is equal to e. Make a as a subject. So 2a is basically 3ae minus 5e. Bring this term here. 2 minus 3e times a is equal to minus 5e. You can multiply both sides by a negative sign. So you will get 3e minus 2 times a is equal to 5e. You get the value of a already. 5e divided by 3e minus 2. That's all. That's the exact value of a. Question number 5 now. Part A is a 1 mark question. We need to find the value of a. So read the question carefully. The temperature T degrees Celsius of the air in a room T minutes after a heat source is switched off is modeled by this equation. Given that the temperature source was switched off was this. That means the temperature was 18 degrees this. They want you to find the value of a. That means basically when time is 0, temperature is 18. Sub in here 18 is equal to 10 plus a e power 0. E power 0 is 1, so a is equal to 8. It's just a one more question. Let's move on to part B now. We have the equation t is equal to 10 plus 8 e power minus bt. Now the question says exactly after 45 minutes the heat source was switched off. The temperature was 16. So you need to replace T by 16 and then there are two T's, one capital T, another one small t. Small t is the time by, you cannot replace T by 45. You need to read the question carefully. It says T minutes. Yes, you are allowed to replace T by 45 times 45. Now we need to make B as a subject. So bring the 10 this side. 6 is equal to e power 8 e power minus 45. B is equal to 6. Divide by 8. E power minus 45. B is 6 over 8, which is 3 over 4. Remove e. The other side becomes ln 3 over 4. Divide by negative 45. B is ln 3 over 4 divided by negative 45. Find the value to three significant figures. So negative 1 over 45, you can write this way also. ln 3 over 4. So the answer is 10 power minus 3. So you need to have a decimal point and 2 0. So it's basically B is equal to 0.00. They want three significant figures, 6, 3, 9. That's the answer. So 3 mark question. Let's move on to part C now. Using the values of A and B. Okay, we got A is equal to 8, B is equal to 0.00639. Find according to the model the rate of change. Okay, when we use the value of B, this is a rounded value actually. So what we are going to do, we are going to use the actual value. So I'm going to store the value as B now. The actual value, not the rounded value. Now the function is t is equal to 16 plus 16 was the function, right? Sorry, 10 plus a e power minus bt. The value of b was negative 1 over 45 blah blah blah. So when you multiply by negative sign, it's 1 over 45 ln 3 over 4 t. Now the question talks about rate of change, so you need to differentiate it. 2 minutes after the heat source was switched off. So you need to differentiate it with respect to small t and then replace small t by 2. So when you differentiate it with respect to small t, the 10 becomes 0, 8 times. Derivative of e power ax is the coefficient of x times e power ax. That's the derivative. In this case, the coefficient of t is this whole thing. So 1 over 45 ln 3 over 4 e power 1 over 45 ln 3 over 4t. Okay, now we need to find the derivative, the value of the derivative when t is equal to 2, after 2 minutes they say. So we are going to replace t by 2. It's 8 over 45 ln 3 over 4 e power 1 over 45 ln 3 over 4 times t. So I'm going to use my calculator. 8 over 45 times ln 3 over 4 times e to the power minus bt. This is basically minus bt. So I have stored the value of b as b already. So minus b times, replace t by 2. You'll get this value. They want the value to three significant figure. So 0.0505. minus 0.0505 is the answer. That's all. So 2 more questions actually. Let's move on to the next part now. Part D. Explain why, according to the model, the temperature of the air in the room cannot fall to 5 degrees. Okay. The equation was capital T is equal to 10 plus 8 e to the power minus bt. We'll use the value of b here. Now, if you take t is equal to 5, replace t by 5 here, bring the 10 here, we'll get 8 e power minus bt is equal to 5 minus 10. So e power minus bt is equal to minus 5 over 8. In order to solve this, if you remove e, this becomes ln of a negative number. Ln cannot be negative, right? So you need to write the conclusion. You don't write this step, doesn't make sense actually. So at this step you need to write, we cannot find the logarithm of a negative number, therefore this equation cannot be solved, and then therefore the air in the room cannot fall to 5 degrees Celsius. That's all. Question number 6 now. We have a figure given and the function corresponding to, representing the figure is also given. The domain is 0 to 2 pi. The curve intersects x-axis at point R. So if you look at the figure, actually the curve intersects x-axis at here, the first point, and the second point is R. Okay. Find the coordinates of, state the coordinates of R. We know that when we need to find the x-coordinate, x-intercept of a curve, we replace y by 0. In this case, y is f of x. So when you replace it with 0, 3 sine x cos x is equal to 0. So when a times b is equal to 0, either a is 0 or b is 0. You need to equate them separately to 0. So in this case, I'm going to equate them separately to 0. E power 3 sine x is equal to 0 or cos x is equal to 0. Here this is not possible because e power minus infinity is 0. So forget about this equation. You don't need to write anything, just a 1 mark question. When you solve cos x is equal to 0, look at the cosine graph. This will be pi over 2, 2 pi over 2, the second solution, second x-intercept, second solution of this equation will be x is equal to 3 pi over 2. So the coordinates of R is 3 pi over 2 comma 0. 3 pi over 2 comma 0, that's all. Because R is the second point, second x-intercept. Let's move on to next one. Show that P and at points P and Q, this P and Q are the turning points. So whenever the question talks about turning point, you need to differentiate the function and equate it to 0. The function is this actually, 2e power 3 sine x times cos x. To differentiate, I'm going to use a product rule. I take the first function 2e power 3 sine x as u. When you differentiate it using chain rule, derivative of e power 3 sine x is the same, times differentiate 3 sine x, you'll get 3 cos x, which is basically 6 e power 3 sine x times cos x. Take v as cos x, derivative of v is negative sine x. So the product rule is vu dash. So 6e power 3 sine x cos x times cos x is cos square plus uv dash. So there is a minus, so it becomes minus 2e power 3 sine x times sine x is equal to 0. So from here we can take e power 3 sine x as a common factor. So you'll get 6 cos square, cos square is 1 minus sine square, minus sine x is equal to 0. We are not solving the equation, we just need to frame this equation. So bring e power 3 sine x to the other side, times 0 becomes 0. So you will have 6 times 1 minus sine square x minus sine x is equal to 0. I think there was a minus 2 sine x. Minus 2 sine x. You can divide throughout by 2. You'll get 3 minus 3 sine square x minus sine x is 0. Or multiply throughout by negative 1. 3 sine square x plus sine x minus 3 is 0. They want us to prove this equation. A, B, C. A is equal to 3. B is the coefficient of sine x. C is negative 3. That's all. Part C says, hence find the x coordinate of point Q. To find the x coordinate of the turning point, we need to solve the equation 3 sine square x plus sine x minus 3 is 0. When you solve this equation, look at the diagram. The first solution will be x coordinate of P. You need to take the second solution to find the x coordinate of Q. So first let's solve this quadratic first. 3, 1, negative 3. Okay. X is equal to minus 1 plus square root of 37 by 6, which is a positive number and between minus 1 to 1 because that's the range of sine x. And the next one is a negative number but more than 1. So x is equal to minus 1 minus root of 37 by 6. This value is more than 1, sorry, less than negative 1, so no solution. It's a sine x because the range of sine x is negative 1 to 1. So we are going to ignore the second one. We are going to solve the first one. First find the principal value, sine inverse of this. I'm going to use radian mode. Sine inverse of minus 1 plus square root of 37 divided by 6. Okay, you see 1.01 whatever the value, that's a principal value. Use the ASTC diagram. Sine would be positive here and here. So here it's theta, here it's pi minus theta. Pi minus theta is the second solution. So you need to subtract this value from pi. I'm gonna put minus pi. They want the answer to two decimal place, so it's 2.131. 2.131. That's the x coordinate of the point Q.